So I'm currently working on the Spike Friends project that is related to the Human Brain project. And what we are trying to do is to build small brains of hardware based on how we think that the brain works, that is spiky neural networks. And these small hardware pieces will be able to control robots like this one that we have here. And the problem that we have is that we don't know exactly how the brain works. So we are just guessing some mathematical models that we use to plug into these hardware pieces that then will be the future of how robots in your house, how robots in the industry will be controlled. I work in basic science, so the impact that I were looking for will be in the future, right? What we are aiming for? Well, first of all, we're aiming for having better systems that are able to adapt to the environment. This is something that is unsolved in robotics. Okay, I'm from the robotics background, and what I want is to give robots the same that humans have, or animals, that is to adapt to uncertainties, right? This is something that we want to do it in short term. What will be interesting in the future? Well, we have chips, hardware that are not smart, but they have some adaptive abilities and they can control systems, for instance, for healthcare, for environmental monitoring, for many applications that we can think about. And in the long run, and this is something that is totally speculation, I would love that the models that I built into the robots, then it would be able to give some hints for neuroscientists to look for new hypotheses. What I can tell you, and this is very important, if we have a digital synthetic implementation in the future of a plausible model of the brain, then we can use these models to actually connect both the robots and the humans at the same time, because in the end they will have the same way to process the information. So then we close the gap between the difference between the robots and the humans.